Okay, solving radical equations. So first thing we want to do is to square both sides to undo the square root. And then we'll solve for x, and then we need to verify that those answers we get are actually valid solutions. So let's start off by squaring the left side and the right side. So that squaring is just undoing the square root. So we're left with what's underneath the square root, 2x minus 3. And if we square 4, we get 16. Now we have a simple linear equation that we can solve. So add 3 to both sides and divide both sides by 2. Okay, now we get that for an answer. When we have an equation involving a radical, we need to check to make sure that it's valid, because our result from a radical can't be negative. So if we plug in 19 over 2 for x, we want to check and make sure that that's equal to 4. All right, well, the 2's are going to cancel, and so we get the square root of 19 minus 3, which is square root of 16, which is equal to 4. So yes, it is a valid solution. X equals 19 over 2. Okay, here is another example. We've got the square root, the radical, isolated on one side of the equal sign. So here's where we can square both sides. We end up with, on the left, just what's underneath the square root. So we don't do anything to that, because all that squaring does is remove or undo the square root. And on the right, we're going to actually have to do FOIL there, because x plus 2 squared is x plus 2 times x plus 2. So x squared plus 4x plus 4. Now we want to solve for x, so we need to just combine terms. So if we add 3x to both sides, we get x squared plus 7x. Add 6 to both sides, and then we get a plus 10 equals 0. So we have a quadratic to solve. I always like to try to factor first, if possible. So we're going to have an x and an x, and the two numbers that multiply to 10 and add to 7 are 5 and 2. We can set both those factors equal to 0, solve, and we're going to get x equals negative 5, x equals negative 2. All right, so it looks like we have two answers. We need to check them in the original, so to see if we get valid solutions. So we'll start with the negative 5. So if we plug that in, we get negative 6 minus 3 times negative 5, so that's going to end up being plus 15. Okay, well, that's equal to the square root of 9, which is equal to 3. Now if we check the other side, right, we've got x plus 2. So we plug in a negative 5 for x plus 2. Well, that's equal to negative 3. All right, so those two things are not equal. Okay, so that means that negative 5 is not a solution. Let's check negative 2. Okay, so plugging in a negative 2, we get negative 6 plus 6. All right, well, that's going to end up being square root of 0, which is equal to 0. Now, plugging in a negative 2 to the other side of that original equation, we get negative 2 plus 2, which we get 0, and in that case, those are equal. So x equal to negative 2 is the solution for this equation. Okay, now we have got radicals or square roots on both sides, and we can still approach this the same way by squaring both sides. Now, we've got that 2 and the 3 that are outside of the square root, so we want to make sure we apply that squaring to those separately. So I just write down this extra step. We're going to have something that looks like this. Okay, so we get 2 squared, we get 4. X, square root of x squared is just x. 3 squared, we get 9. And then square root of x minus 5 squared is just x minus 5. Okay. Next, we distribute the 9. So we get 9x minus 45. All right, now let's get the x's on the same side. So to subtract 9x from both sides, so we get negative 5x equals negative 45. And then finally, divide both sides by negative 5, which gives us x equal to a positive 9. All right, now I need to check that answer. In the original equation, make sure that we get something that is valid. So 2 times the square root 9. All right, we get 2 times 3, which is equal to 6. Now let's check the other side of the equation. 3 times the square root of 9 minus 5. So we get 3 times the square root 4, which is 3 times 2, and that equals 6. So those are equal. So that does give us a valid solution, x minus 9.